hot in here. I had to put this jacket on. It was a little chilly. All right, here we go. Measures of dispersion. Dispersion. What's that word mean to you guys? Dispersion. Disperse, spread out, move out, right? How spread out all these numbers are that we see. There are 4 measures of dispersion, the way we can tell how spread out they are. We're only going to go through 3 of them, though. We decided to eliminate one of them because it's not on the regents. And again, we're trying to shorten this as much as possible, this unit, to get you guys ready, preparing for the regents. One you're probably familiar with, and that's the range. How spread it out it is. The range, how do you find the range? Highest minus lowest. Yeah, so to find the range here of the following test scores, we'll take the highest in the set, which is 98, and we'll subtract the lowest in the set, which is 68, and that tells me the range of scores is 50. I hear someone say 50. 30. Yep. Higher that number, the more spread out they are, right? Lower that number, the more consistent and packed in they are. Now we get some terms that you probably haven't heard of. Interquartile range. I don't know, some people are chiming in. Maybe we've heard it, maybe we haven't. Okay, that's the range in which the middle 50% is. And that can be found by subtracting quartile 3 minus quartile 1. So let's talk first how to break this up, okay? Everyone knows we have the median, right, which is 50% below, 50% above. I have already, you're welcome, by the way, put these numbers in order for you. Can you locate where the median is for me? Locate which number represents the median. We don't need our calculator to tell us. Find which number up here represents the median. 50% below, 50% above. And what are you guys finding? Which score represents the median? 86, yes. There's the median. And now I'll also give it a different name since we're talking about quartiles. It's also referred to as quartile 2. All right, quartile 2. All right, so how do I find quartile 1? That is 50% of the lower half. So what number in here is cutting the lower half in half? All right, so what number cuts the lower half in half? All right, so now I have 86 as my median. I have all these numbers here. What number is cutting that in half? That set of data, it ends up being 77. So we refer to 77 as quartile 1. Which means to us, if you scored a 77 or below on the test, you're in the lower 25% of the class. Okay? Quartile 3, guess what quartile 3 is going to be? Half of the upper half. Okay, half of the upper half. So let's find that right now. And which score are you finding is the halfway point of the upper half? 92, that represents quartile 3. And I heard somebody say quartiles breaks it up into 4s. Well, there's no quartile 4. What the quartiles do, they break it up into 1, 2, 3, 4 equal sections. All right, so my interquartile range, which I abbreviate as IQR, is quartile 3 minus quartile 1. What do we find for quartile 3? 92 minus quartile 1, 77. So my interquartile range will be 15. Okay. Any questions from you guys? And I didn't show you this because I wanted you to understand it by doing it by hand, but your calculator can also do quartile 1 and quartile. I don't know if you guys saw it on Friday or not on that screen we were on, but they can calculate it. All right, and the final one, which is probably the most widely used one, the one we're going to be using, and that is top of the mic. And that is standard deviation. Sound familiar? Yes, no? Standard deviation.
Yes.
Again, it's going to tell us how spread out everything is. I just want you guys to make a note right now. The lower the standard deviation, the more consistent the scores are. So the lower that number is, that standard deviation, which we find by using our calculator, the lower that number is, the more packed in the scores are. So here's exactly what I'm talking about. Let's say you guys just took a test, and you don't need to write this part down. You guys just took a test. So period 3 just took a test. Your standard deviation was, I'm going to go 2.3. My period 6 class took the same test. Their standard deviation was 5.8. What can I tell about looking at those standard deviations? Your scores were closer together. They resembled each other. All right? Versus period 6, they were a little bit more spread out. Everyone's seeing standard deviations doing for us. Here's what I need to do. Go to your calculator right now. Do you still have numbers in your list for me? Do you still have check, stat, edit? Make sure you have numbers in your list for me from Friday. You still got them in there? Okay. Can you go? Hold on. Let me just, I don't think, do I still have them? Yeah, you're darn right. Okay. So go to stat, calculate, one var stats, where we got our mean and median on Friday. Okay. Clear out list 2. Clear out list 2 for me. Just clear. So it just has L1 up there. So you guys just type in L1 into your calculators. All right, calculate. I just want to show you some where these standard deviations are now. Okay, if you remember, this is what X bar. Let's review X bar. That's my mean. And if you scroll down, what we used was the median. And if you scroll down again, you guys see Q1, Q3, the quartiles. So that's where it is on your calculator. Now, standard deviation. If you look on your notes real quick, there's 2 kinds. There's one that we call population, which we get from everybody, the standard deviation from everyone. Everyone see that symbol on your calculator. Locate it on that screen right now, please, so you see where it is. I call it the ox. It looks like the word ox. O-X. Got it, Mark? Good. It should be right here. Everyone, that's population standard deviation. Okay? There's a second kind, which is called sample standard deviation. That's capital S with the X. Everyone locate that one on your calculator. Right above the ox, the population one. So this is sample, and this is population. Take a look at your notes. If the problem does not state which one to use, we assume we use the population one, which is the ox, which is majority of the time, this is where we're going to stay, is with this standard deviation, which is the population one. Okay? If it comes out and says, hey, I need sample standard deviation, that's when I use S of X up here. All right, so these are the 2 standard deviations. Questions on that part before we start finding them now? All right, let's go. Okay, I think you guys are next page now. Next page. I got set A and set B. Without using your calculator to find it, which set had the smaller deviation and how can you tell? Okay, which set had the smaller deviation? Without typing anything into your list, we should be able to tell by looking at it. Remember what I said on the previous page. The smaller the standard deviation, what do I know about the scores? The closer they are together, the more consistent they are. So which one up here should have the smaller standard deviation? B. Why? Because all of them are closer together than set A. Yes. All right. So B, the more consistent the scores. the lower the standard deviation. I'm going to start just abbreviating standard deviation SD. Hope everyone's all right with that. Ready to go? Okay, we got two families, Miller and Lopez. Find the mean and standard deviation for both families. Okay, so let's just find the mean first. Let's find the mean for both the Millers and the Lopez families. You don't need a list to do this, I hope. Mean for the Millers, means for the Lopez. Quickly, mean for the Millers, 12. And then go ahead, find it for the Lopez family. Quickly, 10. Everyone good? 12 and 10. Standard deviation, we got to go to the calculators for that. Okay? So let's go to a list, clear it. Let's go to a list, clear it out. Let's do the Miller family first. So again, stat, edit, clear out. You can clear out both if you want. You can clear out one of them. Won't matter. Depends how your OCD is. It's up to you. Okay, so 10, 12, and 14 for the Miller family. Okay, let's go back to one var stats. How do I get there? I'm going to turn it over to you now. Teach me. Teach me. Stat, calc, one var stats. And I only have it in list 1, so make sure frequency list is cleared out. Okay, so that's what I'm looking at. Hopefully we're on the same screen. It did not say what type of standard deviation, so we assume it's the population. Right, so about, what did I round it to? About 1.63. Right, about 1.63. So O population OX is about 1.63. You guys go ahead and do it on your own for the Lopez family now. Find the standard deviation for the Lopez family. Okay, what are you guys finding? About what? What do I have? 3.67? 3.67? Okay. Based on these two standard deviations, what can you tell me about the spread of their age? I know you don't even need to look at the sample. You don't even need to look at the standard deviation, but what can you tell me? Millers are?
Can you also just look at the range and determine it?
You could too, yeah. These aren't there isn't many of them. But if they listed out, like if I don't know, wild scenario, maybe they had like 30 kids. Okay. All right, calm down. I'm just saying, all right, hypothetically. Since this is the smaller deviation, what can we say about their ages? They're closer in age. All right, Miller family kids are closer in age. Because they have the lower standard deviation. All right. How's everyone feeling, all right? Because we're almost done here. Except we got to answer an A through G question here. Nice. Let's get after it. Got my frequency table, grades in an Algebra 2 class. 5-number summary. I think Algebra 1 maybe? 5-number summary. Did you guys make box and whisker plots? What? No? No? That's where your 5-number summary was. 1, 2, 3, 4, 5. That's where you got your 5-number summary. Minimum. Here you go. Ready? Minimum. Here's your 5-number summary. Minimum value, quartile 1, median, quartile 3, and max. Okay? Good news. Calculator does the 5-number summary for you. It's on that 1var stat screen. So what I need you guys to do, go to L1 and L2. I'll give you a couple minutes here. Go ahead and put in the lists for me. List 1 and list 2. I'll do the same. Why all the negativity to the old box and whisker? Good days. Good days. Actually, I disagree, Matthew, about it's got no point, but maybe one of them, maybe. But if you're comparing two, you can tell. Maybe one's here, one's here. Never mind. You and your new haircut, just keep going. Well, I wasn't there, so I can't help you out. Go ahead. You don't have to wait for me. Get to your 1var stats. Make sure you put in L1 and L2 for the frequency. L2 for the frequency list. Where am I? I just lost my place. 2, 3, 1. Remember how to get L2 in? Right above 2. Second 2. Okay, make sure we all match up here. I'll give you guys a second. Make sure our calculators all match. So our 5-number summary, if you keep scrolling down below, it's all in order for you. Okay, our 5-number summary, here you go. Minimum, quartile 1, median, quartile 3, and the max. There's our 5-number summary. So minimum, 65. Quartile 1 was also 65. My median was 79, also known as quartile 2. Quartile 3, 88. And the max, 100. Okay, find the interquartile range. What did we do before? Look back in your packets if you need to. How do I find the interquartile range? The difference between quartile 3 and quartile 1. So that tells me 88 minus 65, which ends up being 23. It's a pretty big spread for 50% of the data. Mean to the nearest tenth. We should just be finding this right off the calculators now. 79.5. Anybody not seeing this here? Because I'm going to get to something new after this next question. Population standard deviation to the nearest tenth. And that's the ox, remember, population. And that'll be 11.7. Okay, everybody good? Because now this is where it's going to pick up steam for these last 3. What do you got for me there, Goof Troop?
For the mean, I got 85 instead of 79.5, but I don't know why. I got all the
other. Go look back at your table. Go look back at your list. Make sure everything is typed in correctly. One job. Type it in correctly. What's missing? Okay, then here's the next part I'm going to guess. Go to stat, calculate. Did you just put L1 in and forget to put L2 under your frequency list? Yes, you did. Yes. Yes. Yep. Anybody else? Okay, here we go. And this is going to lead into tomorrow now. Stay with me here. How many scores fall within one standard deviation of the mean? Okay, well, we got standard deviation, one standard deviation of the mean. So start with me here. What's the mean? 79.5. How many scores fall within one standard deviation? Well, what was the standard deviation? 11.7. So what I'm going to do, it says of the mean. So what I'm going to do is I'm going to take this standard deviation and I'm going to try to find an interval of scores that fall within 1. So how do I find that interval? I'm going to subtract 11.7 and I'm going to add 11.7. Within one standard deviation. Here was one standard deviation, 11.7. Here's my mean. Within 1 would be anything minus 11.7 and anything plus 11.7. So find that interval right now for me. So when you guys subtracted the standard deviation, what was it? 67.8 all the way to 91.2. So any score between 67.8 and 91.2 will be within one standard deviation of the mean. So now go to your table. Let's figure out how many scores fall within that interval. You give me a yes or a no here. Start from the bottom here. 65, does that fall in there? 65, does that fall in our interval? No, falls outside, so that's not within 1. 74. 79. 85. 88. 94. Okay, I'm just going to stop there. Here's the mistake everybody makes. Oh, 1, 2, 3, there's 4 scores. No, 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 no. Remember what the frequency told us. How many 74s are there? Gotcha, yeah. How many 74s? 3 of them. How many 79s? Okay, so how many total scores here? There's 15 scores. Not 4. All right, they didn't happen once a piece here. They happened more than once. So I got to count the frequency up. Woo! Almost got you. Some of you I did. Oh, our old buddy. What is the probability? Oh, yeah. Yeah, here we go. What's the probability you pick a score that falls within 1? Hey, we did the hard work already. How many scores fall within 1? How many scores fall within 1? 15. This is probability, right? So you got to tell me 15 out of, don't yell anything out. 15 out of, what should it be out of? The total number of scores. All right, total number of scores. How many scores do you have total? We should have 30. 30. Anybody? 30? We're good? And if you just want to, because I know some of you are hardcore and into this whole thing.
Oh, okay.
Instead of, adding all those numbers up, I don't know if how many of you, I'll keep mine's up though. On this screen, you see where it says n equals? That's how many scores you've put into your calculator. Okay, if you ever want to know the total number instead of trying to add them up in your head or on your fingers or toes, they're right here on the calculator, n equals. All right. Oh, was it? Thank you. There you go. That's at the beginning. Thank you, Jess. And finally, find the percent of scores that fall. Ooh, this is a little bit different wording, isn't it? Fall more than 1 above the mean. So not within 1, more than 1 above the mean. So what was our little cutoff point for 1 above? What was our cutoff point, Hannah, for 1 above? 91.2. So what are we looking for now? Any score that is more than 91.2. Because that would be 1. Does everyone see that? 1 above. All right? This was our cutoff point for within 1. So above it is anything greater than 91.2. So go ahead, count up the scores for me. And again, don't tell me 3 of them. How many? 6 of them out. It says percent now. So 6 out of what? 30. Give me that as a percent. Six out of 30 is going to be 20%. All right. Answer keys out, Chromebooks, wherever they're located. Let's get it going. Let's get it going. Easily could finish this before you leave today. Easily.